Hey everyone, welcome back. This is the Everyday Machinist YouTube channel. This video is going to be an update for 2025 and where I've kind of been for the last couple months of 2024. I'm going to have a video out coming soon about fixturing. Right now I'm running these parts in this machine and I go in depth on the fixture that I made. It's kind of a low budget, low cost fixture. Again, I'm using the product to my advantage, the part that I'm actually making to produce this fixture. Instead of spending several $100s or more on certain parts like Mighty Bite clamps or whatever, what have you, I'm utilizing the part to give me the ability to hold it, to be able to put it in the fourth axis and do multi-hole drilling and tapping. They're not super critical parts, but you want to make this quick and efficient as possible. So this is what the part looks like, and we're utilizing 2 of the 4 632 threaded holes that we've done in Op 1 on the part to actually be able to hold it in the fixture here. So that's just pretty much wrapping up, but I want to get to some of the other things that I have in store for the channel, which is Turbo 400 parts, race transmission parts, primarily what I've been making. They've been selling quite well, and we're keeping quite busy with those products. But I'm going to take you over to the other side of the shop and show you what we made here to help us benefit these products that we're putting out there and selling. And then you'll see subsequently videos, clips of what we do, how we manufacture the parts here for the Turbo 400, and then you'll be able to see exactly how we get to test them too. So let me get you over to the other side of the shop and I'll show you what I'm talking about. All right, so what we have here is a transmission dyno. Now it's very basic in its assembly and operation. Obviously it's a custom made component. You can purchase one, they're extremely expensive, but the majority of the parts I've already had here besides the engine. A lot of stuff is individual things like gauges and switch pods, some hoses, some regulators, some automotive components, aluminum. The steel I did purchase for this project, but I did have to go outside and purchase the engine. It is a 1970 230 cubic inch Chevy straight 6. And it works well for this. Now, primarily I'm doing Turbo 400 parts. I am part of a few minor league LDR race teams. And the nice thing about that is we can also test those transmissions on the off season to make sure they're working, or if there's any modification we have to do or repair, we can ensure that they're going to work here. Now, I am not a general transmission repair shop, and I do not do this for the general public as of right now, but there are obviously friends of mine and teams that I'm a part of that this will benefit, so without a doubt I'm going to do that. And the other plus benefit to why I would be doing that for those teams and those friends is because every single one of them that I'm referencing, they run components that I produce. So it'd be beneficiary to me to be able to test those components, see how they're doing, their performance over time, the more passes are put in these cars. Again, it's a straight 6 Chevrolet. It runs off of propane. The theme of the Everyday Machinist, I'll bring in some of the things I did machine to make things easier for myself when operating this and actually when building it. To start off, it is an older engine and it did sat for quite some time. It did have some worn out valve seals. So the intake and exhaust valves, the seals on them, it's the worst design ever in history, just my opinion. But you have to run a stupid heavy oil or else the valve guides are worn out in the head, but the rarity of this thing running for a long period of time, it is what it is. But I did make this very handy tool. So you remove the rocker arm, and I'll put a clip in here of me actually doing it, or showing how it's done anyway. Remove the rocker arm and everything else, and you put a nut on where the rocker stud is, and then you apply pressure to remove. Of course, there's compressed air in the cylinder. But anyway, that's a very simple, quick tool I made here for this, and it's multi-universal. I don't think I can use them on an LS head or any type, possibly a big block head or a small block Chevy head, but for this it works out pretty well. Also too, I'll bring in the camera, get a little bit better depth of exactly what I've done. But with this here, we have a Cadillac CTS, and it's also actually came off of a 2010 Camaro, is a front brake and caliper and rotor. There is a front wheel bearing, wheel hub, okay, that is for a 2010 Camaro, and that's been adapted with CNCing out some plates, and I'm using some CNC linear rail. I have a lot of this stuff sitting around, and this is the only reason this kind of came together as quickly as it did. So we made a little carriage, mounted it on there, and for the purpose of that is to be able to slide our drive shaft in and out of the transmission. And again, it's used to stop or possibly simulate preload. With this, it is an air over hydraulic, meaning I filled the caliper with a little bit of fluid, and then we have air to actually activate it. That's done through a manual switch here. There's no air connected, so you're not going to see that. As well as a safety switch there that has to be depressed for the brake to be released. I didn't want a conventional brake pad just for simple reasons. I don't know if it's going to get too dusty, whatever. So I wound up making aluminum brake pads here. They do hold, they do work. This isn't. This was kind of a test one. Actually, the ones I decided to go with, or decided to alter this original design to get a little bit thicker here, more support on there. I kind of shot from the hip on that because I didn't really have another brake pad to go off of. I wasn't going to buy one just to measure it. So I kind of took some basic measurements of the caliper bracket, and it worked out fine. I have tested this with a big breaker bar and pressure. It's adequate enough for my weight at 200 pounds. So we'll see what happens with this. Again, ideally, we're just either slowing without an intense amount of engine RPM, just slowing it down, back in, idle it down, and then apply the brakes should work. Who knows? We're going to find out here pretty soon, not in this video, and in videos coming up here. So right now, I will bring the camera and I'll kind of focus on a couple of the highlighted things, some of the machine things that we did here, as well as on the carburetor and on the front of the engine. So here, what I wound up doing is, I, again, had a lot of parts. So I wound up making a carriage here, as we see here, with a support bracket. And then we have our caliper bracket mounting with our machined-in pocket for the unit bearing to sit into and get our bolts in. You can see them there. There are three. There is a 1-inch spacer that has the perfect outside profile of the unit bearing, and you have to space it approximately 1 inch away to get the caliper bracket to bolt on and have the correct amount of depth for the brake rotor. This is a used rotor here. I haven't ran it yet. It's just something I did have. We put our nuts on there, as well as these anti-misalignment spacers for Heim joints, which worked out perfectly because it is a tapered ID bore to a flat. So we get to have a nice secure brake rotor being on the hub there. Of course, we got that little screw there. Again, I had the 15mm rail with the carriages. I just wound up utilizing it. What I actually wound up doing, now I didn't MIG all this together. I borrowed a MIG. I do not have a MIG here. I only have a TIG. But what I wound up doing is putting the 3-inch C-channel in the CNC mill, drilling and tapping the holes as I went along. They are 6mm, I think. And of course, another 1/4 inch, excuse me. And of course here I have a 1/4 inch bolt that just goes through to stop the carriage from coming off on both ends. Once I had these drilled and tapped, both of them, I obviously machined out everything here, assembled it all, put it onto this frame, aligned it, and welded it down so there's no reason to be fighting any of the alignment issues when it comes to the carriage. So that was pretty cool. And here we have enough slack in our air hose. I did drill and tap that out to accept 1/8 inch NPT. And then, of course, here we have our air in and our solenoid, which is activated. So I can adjust the pressure too for simulated loads. Now this here is an old Chevy axle. I'll start off here. This is a front CV axle out of a 1994 Chevy Silverado. So I got the CV axle. I had 2 different differentials from a previous 4-wheel drive project. So what I wound up doing was cutting off the original small diameter spline, but I had a boss on this. Now this, jumping ahead, this here is the inner portion of the flange on your front independent differential for the Chevy Silverado. And it kind of has a snap ring on the spline shaft, and it snaps into the to the front differential. So I cut it off, and there was a boss on here that I machined down, machined a slip yoke from a 32 spline shaft. Again, we're doing a 400 here. And I wound up pressing it on as little as I had to press it, and then wound up just TIG welding that around a couple times. So now I have a hub-centric, which this was in the lathe, so it's perfect. Hub-centric from my output shaft adapter. So now I have an adapter here This one bolts from the CV, so I can make several different adapters for different spline counts. Bolts onto the CV axle here. Now this was part of the all-wheel drive. The reason why I had all these components is part of the all-wheel drive Silverado. All-wheel drive Envoy. So what I wound up doing is, this is a different style, but it goes on. It's not the original Chevy 1500. It's designed to go into the original Camaro spindle there. So that works out really well. You can use any. It's just what I had. I could have used a 1500 Silverado unit bearing and brake caliper, rotor, everything. But it's just what I had. It was sitting around, and I figured to put it to good use. So that's what I've done. But if you wanted to do this yourself, you could literally use any. Obviously, you could use steel. I could have welded it. I didn't really care. I just had this. This made it easier for me to do. So that's that. This is a dummy case transmission. I just have it in here for a couple of reasons. Just makes it look appealing while there's no transmission in there, as well as protection of the. I've been running the engine, kind of breaking it in from some of the maintenance I did with it, testing it. I have to add the other 2 gauges I do have here, but this is the basic instrument panel, the control panel there. I got to tighten down the strap on that. We got RPM, volts. When I have these several gauges over here are going to be this is going to be converter charge pressure, so 0 to 300. And I have 2 other gauges here that are going to be 500 up to 500 psi, which is going to be for your main line pressure, which is here. Again, I got to get that squared away. All right, so back to machining. I made a very simple adapter going from the straight 6 intake manifold to this IMCO Model 100 propane carburetor. Very simple to do. Just pretty much mocked the gasket, and then both gaskets, and just made a very simple adapter, basically. And of course, it's clocked differently, so we can still have access to the bolts. Actually, these are pocketed here. Socket head to Allen screws, and so that we bolt this to this and then slip the bolts in, and it's very simple, but that works out pretty well. I got to get a linkage a little bit better, but it's been working for me for just a little bit of time. So here's the propane kit, basically what you see on a forklift that runs in, running off a bottle here. Here's our muffler here. Moving around to the front here, we do have these 2 CNC machine plates just for water. And all we're doing is, I know it may seem like small holes, but it does not even get a tick over 175 degrees in the maximum 3 minutes I'm running this thing, just to quickly test the transmission to make sure it's doing what it needs to be doing. In some cases longer if you're making adjustments, but the runtime of the engine isn't that long. Actually, if you can see right down there, that is a 12-volt pump, an impeller style pump off Amazon, which is plumbed right out of the bottom of the radiator. I got this secondhand for free. I had this old gauge here, and it's funny because when the engine is up to temperature, it barely again gets past that little metal rod for the mercury gauge there, and it works out pretty nice. It's pretty accurate. Our returning from our head goes right here. The water eventually just gets circulated over, so we get an accurate reading of what's coming out of the cylinder head. This does weep a little bit, but again, I'm gonna have to get a catch can for that. I do have to plug these up. We're no longer using any positive crank or anything like that. This thing is indoors, so there's no reason to be running any type of, like a forklift would have, coolant passage going through the evaporator. That's not really that necessary. But all in all, it works pretty well. I wouldn't call it a throw together. It does work pretty efficiently. It's a pretty big enough radiator. It does everything I need it to do. It just works. So we have an oil pressure gauge. The engine makes great oil pressure. I didn't pick the engine up for much money. I think in total I have about $400 into it without the propane kit. Oil pressure is good. We usually idle even when it's hot at 45 psi, so I'm happy with that. All the wiring is pretty basic. I have a wiring bus bar there. This is the emergency switch pedal that's tied in to this switch, which controls that solenoid. Again, I do have to get the other gauges and run the hoses down to be tagging into our converter feed, which on a Turbo 400 here is on the passenger side, which is our to cooler from cooler. So top port's from cooler, bottom port's to cooler, which bottom port would be considered your converter exhaust. And of course, the mainline pressure here. So everything came out really well. A few things got to tidy up, got to get some paint on it, kind of waiting. I'm going to get a pan I have to get bent up and put in there. I got a little stainless splash guard I had laying around, just made an aluminum frame for it. So everything looks pretty good. It's compact, it works, and again, very simple. It runs great. I'm not going to start it up right now. It's kind of too cold outside to be opening the door and throw my exhaust out. This is actually going to get moved once it's all settled and done. It's going to get moved to the other side of the shop where our overhead crane is to be able to put transmissions on. I had a little crane here, but I don't want to. It's my mobile crane. I don't want to use it just solely for that. So, but yeah, everything came out pretty well. I'm excited about it. All right, to wrap up this video, an update where I've been, what I've been doing. I've been working on that, working on making quite a few projects and products for the shop here. Obviously, you saw one of them too. And of course, the other one I have to work on is here, which has been being severely neglected. But I've been spending money buying parts, just letting them sit around. One of the cool things I found, I became a recent fan of this wheel, which is a Bogart D10. This is a Chevy pattern for the rear, obviously, but it's a 15 by 14 wide, and we're going to have a double B blocked by MacFab, and hopefully get ready to go for what is it, Hot Rod Drag Week in September. Pretty soon, coming up in, as they say, in February, registration opens, and I'm sure it's going to go pretty quick. So we're hoping to get into that, and if we do, we're going to be really, really excited. I did have the opportunity to get signed up. I was ready to go, ready to click the button and buy the ticket for Sick Week. Obviously, that's happening right now. They're on day 4, I believe. But I decided to go in a different direction. A lot of other things kind of swayed that. We wound up selling the cast iron engine, and now we're going to be doing some billet goodies for this coming up here pretty soon, which I'm also excited to announce on the channel too. I do want to thank my sponsors for this, which is Forced Induction Turbos. We have 2 turbos sitting right down there. Kind of hard to see, but we'll get a more in-depth video about them as well. And Brian Tooley Racing has been sponsoring us. We got some really nice intake parts and valve cover parts over there, fuel rails, stuff like that. So real excited. Thank you again to those 2 for believing in us and sponsoring us to do this project. I did take a step back from this project only because it no longer is going to be all-wheel drive. It's just going to be a 2-wheel drive project. And it changed a lot of things. Some things happened last year, and I wasn't not upset about it, but it kind of made me think, let's not go down this route. Let's not do all-wheel drive, because I wanted to be doing these bigger quarter-mile stuff, and I'm not crazy about running all-wheel drive in a quarter-mile, especially new to me, being all-wheel drive, new car, new everything. So it's just going to be a 2-wheel drive car. Obviously, we have the wheels here, and we have the fronts coming, so I'm pretty stoked about that. We're going to get the wheels slapped on this thing. We still have a little bit more work to do. We did have to change a little bit of the things in the front end as we took out the 4-wheel drive. So that's why you see some of the parts I had gathered for it are being used in other places. So it works out pretty well. I'll do a quick little, probably a video about this, just kind of where we're at now, where the progress is. Everything has been re-gutted essentially, more cage added, and now it has a full 9-inch and 4-link. It has a wishbone. We have a Cameron Johnson race cars, the average Johnson anti-roll bar in there, which is sufficient for us, what we want to do. And it fits and everything, and we're happy with that product. So great product from Cameron Johnson. Not sponsored. It's just that we if I find something that, the cost-wise, and it's a great product. So you really can't argue with that. So we got some parts on the way. The heads are at the shop for this engine. It is going to be an LS engine. But we'll get more into that as the time progresses into getting this thing ready. So I got the wheel tubs, got the sheet metal, got the framing to finish all that stuff. So real excited about that. Hopefully going to try to carve out some time for that. But that's the gist of the updates for this channel. We are doing machining stuff. You will see a lot of different machining for that fixture, different machines that we're utilizing, and for that same part that I showed before. So you'll get to see that. So I'll try to incorporate a little bit more into there. Again, if you don't know or you do know, can't film everything, don't really care to film everything. It's kind of boring, so I try to get a lot of stuff packed into one video. more like a highlight reel, more or less, of what's going on. And then we'll get to a point where we're going to do other stuff. So a lot of people said to me that know the shop that I have, why don't you do the bead locks yourself? I don't want to. It's not, it's cost effective to send them to somebody else and let them do it. So I'll let them do it. If I get a wild hair at my ass and decide I want to do it, I might do it. I don't know. But they already do it. I figured let the professionals do that. I don't want to get involved with that. But anyway, that's pretty much it as I go about getting things done. I have, again, a full video coming out for that fixture, as well as little bits here. I'll try to put a whole video together and get that out there of the little things that I've done, tips and tricks, fixturing stuff. It's just a lot of little stupid stuff that don't always make up one great video. It'd be kind of stupid. So a lot easier to put out a video like this with somewhat updates. I am pumped too. We're going to be getting some transmissions run on that dyno and seeing what to do. We're going to kind of play mad scientist about it. So I'm pretty pumped about that too. So I forgot to mention that, but you'll see that soon too. I don't care. My goal is to blow transmissions up, and that's what I want to do. Not totally intentionally. I just want to start making things that are so different and wild and see if it's going to work. So that's pretty interesting. But thanks for watching this video. Again, this is an update for 2025 and where we're going to be in the future of 2025. So hopefully, please like, comment on this video. It really helps grow the channel. It really motivates me to put out this content. And again, please consider subscribing, share this with everybody you know who might like this content. Thank you again. And please check back. We're going to have more videos about transmission and truck here.